The Linux kernel. In this nugget and the next nugget, we're going to discuss the Linux kernel. We'll learn how to upgrade the kernel to the newest version so that we're up to date with all the latest security fixes. In this nugget, we'll perform the simplest kind of upgrade to the kernel. We'll use an RPM file. I'll run through it first on the whiteboard, and then we'll move out to the Linux screen and walk through the steps firsthand, one by one. Put on your thinking caps and let's get to work. Alright, well, let's start with some general discussion of the Linux kernel. Now, the first thing I want to talk about is the idea of a monolithic versus a modular kernel. A monolithic kernel has everything inside of it. When you boot up the system and the kernel loads into memory, the kernel has all of the functionality that it's going to need loaded inside of it, resident in memory. A modular kernel, on the other hand, will only have the most essential elements of the kernel loaded into memory when the system boots up. And then when the kernel needs some extra functionality, like a device driver for your printer or something like that, then a module for that element will be loaded into memory so the kernel can carry out that task. Now, a modular kernel, the stuff that's in memory is smaller usually at any one time for a modular kernel, unless like every single module is loaded into memory at once. Then it'll be the same size as the monolithic kernel. But most of the time, the modular kernel is going to be smaller, it's going to be more streamlined and more efficient, and only the stuff is in memory that is needed in memory at any one given time. Okay? So that's why we like modular kernels, because they're faster, they're smaller, they're eating up less resources. Now, the negative side of a modular kernel is that if the kernel needs to do something like, satisfy some print request, then it's got to load that module into memory before it can satisfy the print request. And there is a little bit of overhead in loading that module into memory to do that. But the negative side there is far outweighed by the fact that most of the time you've got a smaller, more streamlined kernel in memory. Alright, so then there's the idea of an initial RAM disk. A RAM disk is just what it sounds like. It's a disk image in memory. Okay? And the reason that we have initial RAM disks on my system, I need one because I've got a SCSI disk as the only disk in my system. Well, the SCSI drivers are not part of the base kernel. Okay, so I can't boot off of my hard disk initially when I boot up my system. I've got to boot off this initial little RAM disk that then contains the SCSI driver, and then it can load that in, and then the kernel can boot off my actual SCSI disk. Okay, so that's the purpose of an initial RAM disk, is to satisfy, in my case, that SCSI driver that's not present in the base kernel. It loads that in, and then I can boot off my SCSI disk. I can boot that full version of Linux. Now, there's a couple options for updating a kernel. One option that we're going to cover in this nugget is installing the new kernel from an RPM file. And not just an RPM file, but like a binary RPM file specific to our architecture. Just like we did when we talked about RPMs before, we had choices for RPMs for various architectures, and we're going to choose the kernel RPM that fits our architecture. The other option for updating a kernel is to customize, configure, install, compile. Alright, well, now let's just go through firsthand those steps that we just talked about on the whiteboard. The first thing that you have to do is get the RPM file for the latest kernel. Alright, I've gone to redhat.com already in the Conqueror web browser here and found the page, and I'm just bringing you right to that page. Alright, so you can see here, generally this is under errata for the particular kernel that you're talking about. So here they said the updated 2.4 kernel resolves obscure bugs. Alright, and now you can see different versions of Red Hat Linux. So the way Red Hat works is that there's an underlying kernel, but that underlying kernel version could be running on multiple different versions of Red Hat. Okay, the reason they release new Red Hat versions is because something on the surface changed, maybe a graphical user interface or something they've added, and then they put out a new version of Red Hat. Okay, and so you have to pick the right version of Red Hat Linux that you have in addition to picking the right kernel version. So I'm running Red Hat Linux 8.0, so I'm going to click there. And now there's going to be a bunch of RPM files here as I scroll down for Red Hat Linux 8.0. And the first one here is source RPMs. Okay, so the kernel version is 2.4.20-20. The 0.8 there just means it's for Red Hat 8.0. That's a Red Hat thing to add that extra digit on the end. And you can see here it's a source RPM file. So if you're going to mess with the source code, do some development, if you're just extremely curious or you want to customize things and reconfigure and recompile it yourself, this is what you have to install on your system. Okay, we're going to not do that right now. Right now we're going to take the easy route and just take the binary RPM that's specific to our processor. Alright, now for me, I've got an Athlon processor. If you're not sure what kind of processor you have, go out to the shell window and just look at proc/CPU info. Print that out to the screen and it'll tell you all about your processor. You can see here I have an authentic AMD and the model name is an AMD Athlon processor. Okay, so that's what I'm going to use, and you can pick whatever is specific for your processor, a 586 or 686 or whatever. Okay, and you can see here for an Athlon there's a 2.4.20-20 kernel for an Athlon. There's another one down here with the same version number for an Athlon, but this one says SMP. Okay, SMP stands for symmetric multiprocessors. So if you have more than one processor inside of your computer, then you need to install the SMP version of the kernel so that you can utilize both processors, or however many processors you have. If you have 4 processors, whatever it is, so you can utilize the multiple processors inside of your computer. Okay, that's what that one you'd have to have. They recommend that if you're going to do the installation of an SMP kernel, that you also install the non-SMP version of the kernel. In case there's a problem there, you'll have this one as sort of a backup, so at least you can use one processor in the interim until you fix what's going on. Okay, so that's a word of warning from Red Hat. As we scroll down the screen here, you can see there's a section for Intel 386 processors, and this is kind of the default section. If you don't know what processor you have, or the processor that you have is not listed explicitly in this list as we go down, then this is the section for you. Okay, so at first, you know, we've got the plain old Intel 386 RPM. Then we've got a boot version, and this is to make an installation boot disk. Doc is for kernel documentation. If you're just upgrading the kernel, you don't necessarily need the documentation. Kernel source, again, that's source code for the 386 processor. Okay. Now as we go down, we go to Intel 586. Again, there's a regular version and there's a version for symmetric multiprocessors. And then as we go down to 686, there's the regular version. There's the Big Mem version. So if you have more than 4 gigabytes of memory in your system, then you need to make sure that you have the Big Mem kernel. Alright, if you don't have more than 4 gigabytes of memory, don't worry about it. Notice that 4 gigabytes of memory is only supported for the Intel 686 processor right now. And then there's an SMP version for the 686 processor, and that's the end. Now we're down to Red Hat Linux 9. Okay, so the one that I'm going to take here is going to be this Athlon RPM, just the basic one, and that's the one that we're going to install on my system. Okay, now let's look at, see this number here? Let's talk about what this number means. So if we go out to the Linux screen here, I've actually already downloaded that Athlon RPM. Let me just switch over to be the root user. And then let's do a listing in the /temp directory for everything that starts with cur. And you can see I've already downloaded 2.4.20-20.8 Athlon RPM. Okay, now what I can do is I can do what's called an MD5 checksum on that particular file. Okay, and what I do is I get this number back. Okay, this crazy number, 9EB393, exactly, okay? Now what I'm going to do is I'm going to come out to this screen, to the web page where I downloaded that from, and highlight this, and come back and just paste it in the window right underneath that with the middle mouse button. Okay, and now we can compare these two. And what we're comparing here is we're comparing what's called the MD5 checksum. It's an encoding of the file. It's sort of like a fingerprint for the file. Unlike fingerprints, 2 files could have the same MD5 checksum, alright? But the number of fingerprints that are out there is like the square root of the number of atoms in the universe, or something ridiculously large like that, okay? So the point is that if these two things match up, it is very, very highly likely that the two kernels, the new kernel stuff alongside of it in the /boot directory, we're going to see a new stanza in Etsy grub.conf, for instance, as well. Okay, so when this is finished and I actually get my prompt back, we'll go look at the grub.conf file, and we'll go to the /boot directory and take a look around there. Okay, so let's go to the /boot directory first and do a listing. All right, now in there you can see there's a config file for the old kernel version number, and there's a config file for the new kernel version number. There's an initial RAM disk for the old kernel version. There's an initial RAM disk for the new kernel, okay? And so on, module info, system maps, and the actual kernel itself for both versions of the kernel. Okay, so all the stuff there is now just duplicated. Okay, all the kernel stuff for the old kernel version, there's also a copy of it now for the new kernel version. And this is why we don't want to do an upgrade, because if something went wrong, all this old kernel version stuff would be deleted, and it would just be replaced by the new kernel version number instead of being alongside of it. Okay, now let's look at the etc grub.conf file. Okay, now in this file, remember, I said there was going to be a stanza for each of the kernel versions, okay? And here are the two stanzas. This stanza is for the new kernel version, okay? And this stanza is for the old kernel version. All right, remember though that stanzas, the stanzas here get labeled. The first one is number 0 and the second one is numbered 1. Okay, and up here you can see the default is number 1, which means by default the first stanza is going to be booted if you don't make a choice, and the first stanza is really the second one because we start numbering at 0. Okay, so the one that will get booted by default is the old kernel, not the new kernel. But when we go and shut down the system and reboot it, and we get to that grub screen, we're actually going to have a choice of which one of these we boot up, because there's going to be two options in there. Okay, and that's what we're going to do right now. We're actually going to go and shut down the system, and then when we shut down the system, we'll come back and I'll show you the boot screen, the grub screen, where we actually have our choice, and then we'll come back and boot up the and change the default variable so that it boots off of that new kernel. Well, I hope you found this nugget informative, and thanks for watching, and stay tuned for the Linux kernel part 2, where we're going to learn how to customize and compile the kernel ourselves.